Hello guys. So I'm gonna try something that might help for my just not only my personal exam P studying, but maybe this video might help someone else out there who also is studying for exam P. So we'll get right into it. So let me pull up my writing software. Let's go to OneNote. Okay, and let's open a new page. Okay, so we're going to be doing number 159 from the SOA's sample problems on the SOA site. So this problem, I'm going to pop it up and allow you to write it down if you'd like to pause the video. But the problem states, two fair dice are rolled. Let X be the absolute value of the difference between the two numbers on the dice. Calculate the probability that X is less than 3. Okay, so if you need to pause the video to write the problem down, go ahead. So we're told that X is the absolute value of the difference of the two numbers. So let's let X1 be the first roll. And then let's let X2 be the second roll. Okay? So from the problem, we know that X equals to the absolute value of the difference. So this equals X1 minus X2. That's just the notation for the absolute value of the difference. So, and then we're asked to find what is the probability that X is less than 3. Well, since this is a discrete problem, we know that the probability X is strictly less than 3 equals the probability X is 0 plus the probability X equals 1 plus the probability X equals 2. Okay? So now we get to come to the fun part. So what I'm going to do is, there might be a different way to solve this, but what helped me for this problem is to write down all the possible outcomes for each roll. So we know a 6-sided dice has 6 possible outcomes, 1 through 6. Okay, and we're going to roll it twice. So we need to write down all the different outcomes for 2 separate rolls. So when you roll a 1 first, here are the, well, actually, I'm just going to write down all the outcomes and then I'll explain. So we do 1, 1, 2, and so on. So you definitely can see the pattern. And then when you first roll a 2, you can get a 1 and so on. So you can definitely see, I'm literally just writing down every single possible outcome when you roll 2 dice. We've all played dice games like Monopoly, and so this would kind of be kind of cool if you're not even into probability to kind of see, what are the probability that you might roll certain combinations, right? So I'm just gonna keep writing all the outcomes. We'll be done in a second. There's probably a different way to solve this. For this problem, I didn't even look at the SOA solution because I just feel like it's easier for me to write down and see and kind of visualize all the different possible outcomes. So we're almost done writing down all the outcomes. All right. So now we have all the possible outcomes when we roll 2 dice. So you can see that there are 36 possible combinations when you roll 2 dice, right? We have 6 on the top and then 6 here. So you can just do 6 times 6 and see, oh, okay, we got 36 possible outcomes. So I'm right over here, 36 possible outcomes. Okay. So we have everything we need now. All we got to do is kind of look at our little outcome, all the outcomes we drew, and kind of just draw from there. So the probability that X equals 0 is what? Well, we know X is the absolute value of the difference of the 2 rolls. So when X is 0, that implies we need to roll the same number both times. So as you can see, that there are 6 possible ways to do that. You can roll 1s both times, you can roll 2s both times, all the way up to rolling both 6s. So we know that this is 6 divided by the total amount of outcomes, which is 36. So this is 1/6. All right. The probability X equals 1 is the difference between the 2 rolls being 1. So that would be like, right here would be 1, 2. would be 2, 1, 2, 3, or 3, 2, 3, 4. So you go down all this list, you see there's 1 here for when you roll 1 first. So I'm going to write 1. For the second row, we have a 2, 1 and a 2, 3. So there's 2 ways. With the first roll of 3, you have either 3, 2, or 3, 4. So that's 2 more possible ways. For the 4 row, you can either get a 4, 3 and a 4, 5. So that's 2. For the rolling a 5 first, you can either be a 5, 4 or a 5, 6. And then when you roll a 6 first, the only way to do that is when you roll if you roll a 5. So there's just one outcome on that row, all divided by the total possible amount of outcomes, which is still 36. So this fraction ends up being 5/18. All right. Lastly, we need to find the probability that the difference between the two rolls is 2. Okay. So for this one, we just kind of do the same process. So it has to be a difference of 2. So if you roll a 1 first, the only way to do that is if you roll a 3. So that's 1. If you roll a 2 first, the only way to do that is 2, 4, right? So that's another just one way if you roll a 2 first. If you roll a 3 first, there are 2 possible ways to do that. If you roll a 1 next or a 5 next, that's 2. If you roll a 4 first, there are 2 ways. You roll a 2 next or a 6 next, so that's another 2 possible ways. And then lastly, if you roll a 6 first, the only way to do that is if you roll a 4. So it's just 1. This is all over 36. So this equals the fraction 2/9. All right. So now we just have to plug these 3 values into our goal equation. I should have wrote up here, but this is our goal, right? So finally, the probability that x is less than 3 equals, well, we know the probability x equals 0 is 1 over 6. So 1 over 6 plus the probability x equals 1, which is 5/18, plus the probability x equals 2, which is 2/9. Plug that into your calculator, and you end up getting the final answer of 2/3. All right, so that's just a quick little solution to exam P sample problem 159. This just deals with a lot of like basic probability and possible outcomes. So as I continue, studying for exam P over the next few months, if I find a problem that, I feel like, it would really be good for someone else to see, I'll definitely be, might be doing this more often. So if you think that this would be something you would like, just let me know, and thank you for watching.